Hi, this is Andrew. Thanks for joining me. This video is about subnetting and picks up where my previous subnetting video kind of left off, where we have subnets created. So basically, the previous video covered subnetting on an octet boundary. So right where the dot is in an IP address. In this case, we're going to say, let's take subnetting and do it not on an octet boundary. So we're going to say we have two subnets, 192.168.1.0 and 1.128, and they're both /25 addresses. So what this will allow us to do is, if we're in a situation where we don't have, where we're starting with a subnet that is not evenly on an octet boundary, we can still break that into smaller pieces. The other thing this will allow us to do is a variable length subnetting. If we're the ones who created this first batch of subnetting, in this case we broke 192.168.1.0 into two separate subnets, now we can break the second subnet into 2 or 4 more subnets, or as many as we need. So first thing is, let's remember we're only looking at this fourth octet. That's our octet of interest. So for 128, what that means is that the let's copy this. As always, this is just, I always have the binary values there because it helps me to understand what's there. So this second subnet, 1000000, and all we care about is that this one is part of the network address. Let's do that in green. Everything else is part of the host. So we're going to basically break this up using only our host bits. So let's say we need 4 networks. In order to do that, we have 2 to the n, so that means 2 times 2. We need 2 bits to get 4 networks. And what we're going to use are these 2 bits. So we're going to create 4 networks, and in this case, the first network is 1, and then we have 0, 0, 0, 0, 0, and what we have here for our new network is, this is still part of that old portion of the network. Then we're going to use a different color. We will use yellow for our new, yellow's not as visible as I'd like. Well, that works. So we're using yellow for our new network bits. So in this case, what we've done is we have a new subnet mask that has the original network bit and 2 new network bits. So that creates a /27 because it's a 24 from the first 3 octets, and I need a dot there, and then we have 3 more bits here from this octet. So what do we do next? We just keep counting. So remember that 1 stays the same, and in this case we're going to do a 0, 1, and then zeros. And I'll come back and color them in completely. 1, 1, 0. And all I'm calculating are the network addresses. I'm not doing broadcast first last. That's the same pattern we've used before. So now this last one is 1, 1, 0. So we have this one is green, this one is green, and this one is green. Now, same pattern. These are yellow, yellow, and yellow. So we're doing the exact same thing we did before. We're just counting in the bits that we're using. Now in this case, we can't change this 1 because we're starting with this network. We have no option of using anything that would put a 0 in that first bit for network, because that's all used up by this network. So all we have to do is convert these into decimal to figure out what they are. So after the 27, I will just do a tab, and we have this first one is 128. 128. The next one is, we'll do a slash 27, and this is 128 plus 32. That's 160. Now we'll do a slash 27. All of these are slash 27s, and at times it can be important to make note of that. Right now we'll just do slash 27, but really what we have is 192.168.1.128 slash 27. So this one is 192, and our last one is slash 27, and this one is going to be 128 plus 64 plus 32. So that's 192.224. These are only half of the address space. The other half is taken up by that address. So if we were doing variable length subnet mask, we would have a 0 here. And in this case, this 0 is our green bit. And we don't have any yellow bits here because this address is a slash 25. So that's variable length subnet mask we just did. By breaking up one of the existing networks into smaller pieces, we're able to figure out that the 0, it covers all of the addresses here, and then the 1 covers everything in this second space, and we're just breaking that second space up into smaller pieces. So if I don't want to do it in binary, I can use this magic number again. I'll do this over here, and then I'll kind of talk you through that part, and then we'll maybe do one more example. So over here we have 192.168.1. I'm going to ignore the .0 and just look at the 128, and that is a slash 25. Now we know we need 4 networks, so we have 2 more bits, so we go to, we're going to say now we're doing 192.168.1.128 because that's where things will start, but it's going to be a slash 27. And now we need to calculate the rest of the networks out. Since the slash 27 puts us in the third spot, the magic number is going to be 32. So I'll do that as red. That's our magic number, 128, 64, 32. So we're counting by 32s. So that's our first network. Our second network is 168.1.160, which is just 128 plus 32. Slash 27. Our third network, 192.168.1.160 plus 32, 192 slash 27. Our fourth is 192.168.1.192 plus 32 is 224 slash 27. And if I did the math one more time, if I didn't realize that I had 4 of these, I would get 224 plus 32 is 256. And that's too many. That's too many numbers, or that's too large a number to represent with 8 bits. So it kind of just tells me that, yes, I've gotten to the end. So that's all I do for variable length subnet mask. Now, if we wanted to start over, or let's go with a different number, we could come back here. Let's clear everything out. Clear everything out here. The beginning doesn't really matter. This could be anything we want. So I'm going to make it 10.10.1.0, and we're going to start with a slash 26. And we're going to break that into 4 networks. So, well, first, what are these slash 26 networks? Because that's broken into, that takes the slash 24 and breaks it into 4 networks. Well, the 26 puts us in the magic number of 64. So 10.10.1.64 slash 26, 10.10.1.128 slash 26, 10.10.1.192 slash 26. Let's fix this one, slash 26. So that's just quick subnetting. That's just 10.10.1.0/24 broken into 4 networks. So that puts these 2 networks as our green in this case. Now what do we do next? We're going to say, let's do 2 more networks. So that'll put these 2 bits as our yellow bits this time. So now we're doing a /28, and we're going to look at that network. So let's bring this down. This is our network. We're breaking into 4 more networks. So I'm going to not do it based on the binary method. I'm just going to look at my 16. So we now are, instead of a 26, we're at a 28. So it's 10.10.1. And now we add 16 to 192. And that is 208. And I'm just verifying my math. Then we do 10.10.1. And we add 16 to 208. And that's 218, 224/28. And then another 10.10.1. And we have 16 plus 224 is 230, 240/28. And again, we add 16 to that, we get 256. That's too many. So that is variable length subnetting with 3 subnets of equal size. And then the 4th subnet is broken into another 4 subnets. So that's just based on numbers we picked. There's no reason beyond me saying, let's try it with 3, let's try it with 4. In this scenario, these networks have 6 host bits. 2 to the 6 is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, and minus 2, because we need to set aside the network and broadcast address, is 62 hosts. Now this one is also 62 hosts. Obviously this one is also the same size, 62 hosts. And then we get down here, and what do we have here? We have 4 bits for hosts. 2 times 2 is 4, times 2 is 8, times 2 is 16, minus 2 is 14. 14 hosts. So 14 hosts. 14 hosts and 1 more. 14 hosts. Now we could keep going with this. We could say, what if we want this last network broken up into more pieces? If we're using a point-to-point link, we only need 2 addresses in there. So we could break that last network into more pieces. And it would be the same process, except now instead of these bits, we're just going down here, and we'll make those the purple network. So we'll bring that down. This is now, instead of 28, we're saying we need 2 more bits, so it's going to be 30. And no longer 14 hosts. We'll come back to that. Now all we're doing is we're saying, what's the next one after 240? We add 4 to that. 10.10.1.244/30. 10.10.1.248/30. And 10.10.1.252/30. Now this is, again, easy math. We have two bits left. 2 times 2 is 4, minus 2 is 2. 2 hosts. And this time I will just copy and paste that one, and paste and paste. So now in this case we have 3 networks with 62 hosts, 3 networks with 14 hosts, and 4 networks with 2 hosts. So much more commonly what you'll run into is take the 3rd network, break it in half, take the 4th network, break it into smaller chunks, that kind of thing. Any way you look at it, you can always take a network that doesn't exist on a boundary, 10.10. In this case, 10.10.1.192, and it was a /26, and we broke that into 4 more networks. And then we broke the last one, 10.10.1.240, and broke that into 4 more networks. So you can always follow this same process for doing that. So from here, we can obviously figure out first, last, broadcast, all of that stuff. In this case, the broadcast is 63, first is 1, last is 62. Just fill in the chart for the rest of it. So that's all I have for you today. Thanks for watching.